Okay, I promised to make a separate video about the truth tables. So truth tables are just a convenient way of organizing the truth values of various statements. So before we get into that, we need to do a quick review of negation, conjunction, and disjunction. So as you can recall from class, when we have a statement P here, we use that weakly thing, say not P, to represent its negation. And the definition is pretty simple. If the original statement P is true, obviously not P is false. And if the original statement P is false, not P is true. So that's just to negate the original statement. Conjunction is expressed with this hat, and we call it and. So it requires both values, both statements, the truth value for both statement P as well as statement P to be true so that P and Q can be true. But if one of them is false, like in the second example, the conjunction P and Q is false. And same thing with this one and the last one, both are false, and of course we have a false there. Okay, disjunction is this little thing there, and that we call it or. And for P or Q, as long as one of them is true, then we have true. So the first one is true, the second one is true because of this true, the third one is true because the truth value for Q is true, and the last one is false because both P and Q are false. So that's how we construct a truth value, a truth table. So we're going to do some examples below, some more elaborate examples, but just to summarize what we just learned, in order to construct a truth table, first you need to include columns for each original statement involved. So in our example above, we had P and Q. In the examples below, we have sometimes 3 statements or even more, right? And so once you have the original statement involved in each column, then you want to add on the negations required. Whatever is required, not often that all 3 are required, maybe just 1, maybe 2 out of 3, or maybe more than 3 is required. Whatever is required in the original problem provided, you put that down. And finally, you include columns of the compound statements. So let's take a look at how that's done. In the first example, P or not R. So we said first we have to have our original statement. In this case, we have an original statement involved. So in this case, we have P and we have R. And secondly, we need to put down the column, the negation that's involved. In this case, we only are negating R, so we put not R here. And then finally, whatever is asking, the final compound statement always goes to the end, to the big box. So let's look at how we do this. When we have 2 statements, we always do, this is always the case, true, true, false, false for the first statement. For the second statement is true, false, true, false. Okay, this exhausts all possibilities, all 4 different combinations of statement P and statement R together. And then next we go just to negate. We just need to negate the column R. So if R is true, not R is false, and vice versa. Right? So finally, we are looking at P or negative R. Right? We're looking for a negative. We're looking for P or not R. So the columns that we need to pay attention to, let's see if I can do this in the highlighter, is the column P, which is right here, and the column of not R. Only these 2 columns we need to combine them. And because it's an or statement, as long as one of the two columns is true, my final answer is true. Second one, both are true. Third row, both are false. And last one of them is true. So for an or statement, disjunction, that as long as one is true, the conclusion is true. So that's how we construct a truth table with two elements. Now let's take a look at the second example. We have not P and Q. Again, we put down the original one there, and then we only need, in this case, not P. And then the final problem, the entire problem, goes into the large box. And because it's two elements, we do true, true, false, false, true, false, true, false. That's just to make life easier for us. And now we negate the P statement. So not P becomes false, false, true, true. And then finally, we are evaluating not P and Q. Because it's an and statement, it's a conjunction. Both columns have to be true in order for the final statements to be true. So this would be false, this is false, this is true, this is false. Okay, so I'm not going to do 3 and 4, but I will write out what you need in each column and you can proceed from there. So for 3, it's you need Q, and R, you need not Q. So your final conclusion, the two columns you're looking at, is not Q and R. And the last one, you need P and R statement. You also need not P, right? And you also need not R. And then your final statement is not P and not R, which means you're looking at this column as well as that column. So to go back to our original point is you do need to write out the original two elements. In this case, is P and R. And then you figure out what are the negations that you needed. In this case, you need 2 negations. I'll leave number 5 for you to do. And number 6 is it has 3 elements. You do it exactly the same way. So you have 3 statements, not elements. You have P, Q, R. In this case, it doesn't look like you need a negation. You don't need negation for any of the statements. However, and your final conclusion is your last box, Q and R, right? But before you go to your final conclusion is comparing the column for P versus the column of Q and R. So you put whatever is in the parentheses in between, so that you're comparing these two columns. Now, since we have 3 elements, for 3 elements, we do 4, true, 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 false, 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 false. One easy way to break it down is actually to count the number of rows they have, and you just split it for the first element. Half of them are true, half of them are false. And then you, for the next element, you further break down into 2 of them are true and 2 of them are false, and the second half you just repeat that, true, true, false, false. And the third element, for the first statement, now you do true, false, true, false, true, false, true, false. That pattern just keeps going on and on and on and on. It gets reduced each time. So now if you look at Q and R both has to be true in order for it to be true. So that will be true, false, 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 right? Q and R is this column. I should use a different color. Let me use blue. Is this column and this column that you're comparing. So I should write this with blue, Q and R. And now it's true. These 2 are false, false, and false. right? So that's Q and R. And finally, we're looking at P and Q and R. So we're comparing P is here, and this is an OR, so it's this one. So of the two green columns, or the two columns with green arrows, as long as one of them is true, my final statement is true. So this is true, false, which is true, true, false, which is true, and this would be true, false, false, false. Make sure you double check my work, but that looks right. Okay, so that's example 6. I think I'm gonna stop there. Well, there are 2 more. So I'm going to do this. I will lay it out for you for number 7. So you have PQR. You have PQR. Now you have not Q, you have to find out. And then you need to find out P and R. So your final comparison is not Q and P and R. And because there are 3 original, we just do what I talked about, split it in half. Half of it is true, the other half is not true, and then the second column would be 2 true, 2 false, 2 trues, 2 false. The third one is true, false, true, false. If you forget this, the trick is to, like I said, is to exhaust all possibilities. You've got I usually just put everything in the first column true, and then figure out the next 2 columns and make sure that I have all the possibilities given. Okay, so from there on, you figure out all the remaining columns and see what your final answers are. I'm not going to do it for you. Answer keys are online, but I hope this clarifies some confusions. Okay, guys, I will see you in class. Thanks, bye.